Those are called neurons.
You're going to have multiple iterations of the same decision being made by different, repetitively, by each neural group.
You mean in my training?
I'm saying to check out, say if this is a real rock, you say I want to check out this rock. You have multiple nodes. Are they not all doing the same thing? That's what I don't understand. The
No,
brain nodes,
they all will have different formulas for them.
They have whites.
What?
They have whites.
That's one aspect of the machine.
And they're being modified.
Yes.
Weights, you said?
Yes, but that's not the only way of doing it. Weights is one form. There's a lot of ways. This is where people get PhDs in artificial intelligence. It's how do I define, in your case, a weight that I'm gonna multiply by this. Let's say 0.76. You can say I'm gonna add multiply it by 2x. So whatever number comes in, it's gonna be by 2x. This is gonna be 3x, 4x. They can have something called a bias. I don't want to get into it because it really is gonna get too confusing. But let's say you can add a bias saying I have to limit the output of all of these green nodes to be between -1 and +1. There's a lot of assumptions you have to make. So that's why you need a human who understands the business problem that you're trying to solve to model it correctly. And if you try to platform, it's really not gonna know all the assumptions you have. But yeah, weights is one way of doing it. That's one of the popular ways. But there's multiple ways to do it. You can have a derivation. You can have a derivative function. And you can get funky with it. So, no, but I want to make sure everyone understands this. So I know it's a little bit, I was thinking of getting into a little bit of mathematics, but really I don't want to because I wanted you to understand that this is, well, there's more things we're going to talk about. So each neuron will have some mathematical factors. We talked about this. Now notice the value propagates forward. The neuron, the hidden layer talks to the output layer. It's called hidden basically because it's shadowed by the input layer, meaning that you couldn't call it the middle layer because it's not really a middle layer. It's hidden between input and output. Now, what you need to know here is that this doesn't have to be one layer only. It could be multiple layers deep. This is where the term deep learning comes from. You'll have multiple hidden layers on top of each other. Now, well, how does that help with everything? Because each hidden layer might process one thing and send the data to the next hidden layer and the next hidden layer, again, depending on the architecture of the algorithm. And each hidden layer would kind of work on one thing specific. An example of this would be, in computer vision, for example. Let's say I take a picture of everybody here. We have our own computer vision algorithm. So at my company, if we don't have projects that work on, we do our own R&D. Let's say I take a picture of everybody here. The first thing the computer vision is going to do is try to find lines. One hidden layer is going to find vertical lines. And says, okay, in this image, I find these vertical lines. I'm going to send it to the next hidden layer. I don't see that.
15 minutes.
Okay. Yeah, we're close. Well, yeah. The next hidden layer is going to find horizontal lines. The next hidden layer is going to find someone's face. If I find the face, the next hidden layer is going to find the eyes. And slowly you find one hidden layer at the end that compiles everything together and says, okay, I think there's something happening here, there's a meaning or something. But the deep learning term comes from having multiple hidden layers on top of each other. How deep you want to go is up to you. But you can only imagine, when I tell you these mathematical functions are complex, they take a lot of computing resources. So when I hear hype about the explosion and the AI and all this stuff, so each neuron would have arbitrary values. We talked about this. We're mimicking human learning. This is based in the behavioral psychology. That's how a baby would learn. You know, it doesn't know how to walk from the beginning, so slowly it starts learning it. Deep learning is multiple hidden layers deep. Neural networks are 50 years old. This was invented 50 years ago. There's nothing new in this. All of this AI stuff happens in the 65 and way back in the 60s. What happened is basically, once you go deep with the hidden layers, the computing resources become too expensive. There's no computers to do that. So what happened recently is that we have cloud computing. Computing is much cheaper. You can spin up much more processing power. GPUs, graphical processing unit, which are very good for handling neural networks, are becoming much cheaper because gamers like to play. I'm a gamer too. I like to play video games, and because you want to make sure your frame rates are very nice. Companies are building GPUs. Google announced TensorFlow. They have their own TPU, TensorFlow Processing Unit. It's a specific hardware built for AI. But that's really what happened. Computing is cheap. That means AI has gone through winters. In 65 it was big because the NSA and the Army was pushing a lot of research. And then they didn't like it, or it went through a winter in the 80s, and it went up again, and it went down, and now it's up again. But really nothing, up until I haven't mentioned the word philosophy or consciousness or cognition, cognizance, but that's what happened. Cloud computing, cheap computers, but the setup really is the same. Now if you talk to someone who's doing research, you might find a specific silo, but it's still using the idea of a neural network. What I said still applies. Input, hidden, output layer. Go ahead.
Yeah, there's another reason why there's been a revival of neural networks, and that is because storage has become so inexpensive, it's now possible to train with massive amounts of data that you couldn't do 20 or
Yeah.
30 years ago.
So chip computer, okay, I lied to it, yeah. But yeah, basically, and that's another good
The
point.
combination of massive storage and intense GPU power, right?
And cheap.
And the cost of going
Yeah,
down.
cost of running it is very cheap. Amazon AWS, for example, for our own algorithm, because I don't talk to investors, I don't want to talk to venture capitals, whatever money we make from projects, we invest back in the company. So we have run our own servers, and I try to build the optimal algorithm, but there's something called an FPGA, which is a GPU processor. Anyway, Amazon is even providing cheap access to servers that can process AI engines. Okay, what were we talking about?
As a service, they're doing it.
As a service, yeah. So, for example, I'm not gonna demo my AI because every time I take a picture, it's gonna cost me like maybe $2 just to analyze the image of something. Not $2, but you know. So, deep neural networks that we've been practicing recently. Do you have any more questions about neural networks per se, about the way it works? Or is it clear to everybody? This. So, green layer can go multiple layers deep, and the deeper it is, the more expensive it gets. But the same way the human brain works, each neuron doesn't know what it's processing, doesn't really have an idea of it, but the huge interconnected layer of network, of neurons, kind of build an understanding of abstract ideas. That's how the brain works, basically. Or that's how the behavioral psychologist, and when I forgot his name, Marvin Minsky, one of those guys in MIT, Minsky, he's the one who started the think about it, they try to model it based on the human thought process. So as you can see, it has nothing to do with statistics. We're way far from machine learning and from confidence intervals and stuff like this, at least from decision spaces and boundaries. So basically, Google and Facebook, they demoed their own face detection with Deep Neural Network that were able to pick up humans very easy. And it was really a big deal in 2015. Now, algorithm doing a lot of cool stuff, sophisticated stuff, autonomous car driving, medical diagnosis, translating human speech, that's done to do with deep neural. But still, the idea of translating is different than recognizing it. Right. It's from like French to something else. They're still very sophisticated algorithms. Again, I don't know if I should call them intelligent, the way we call humans intelligent. That Siri can translate this, but it cannot pick up dry cleaning afterwards, or know how to take the A or the jump off the A because there's something at 42nd Street. I got to switch to the L at Union Square. It doesn't know how to make these decisions. So AI so far is called weak AI or narrow AI. It works on a specific task intelligently, but it's a very structured task. Identifying rocks, driving cars. I'm not saying it's not useful. It's very cool that we do have this. But I don't know if we needed to compose music, for example. I'm sure you guys have seen, I've seen demos of startups, the guys building an AI to build music. All right, that's cool, but I don't know if it's needed. Or cook recipes. I don't know if that's something that you need AI for, but it's cool that it happens. Strong AI, or general purpose AI, is what computer science think would be a human level artificial intelligence. It has not been produced yet. A lot of people say it will never have to, it'll never appear. But so not demo, but maybe never. But I will say that there's a lot of digitized content that we have. We have Wikipedia, we have Twitter feeds, we have web pages, you have audiobooks. Go ahead.
Well, a little off from what you're talking about, but wouldn't the current generation of robotics fall into that category?
Of what?
Robots and robotics.
In what category?
Strong AI.
No. What robot can write music, and can robots do multiple tasks?
I've read that some are getting there.
Intelligence also.
But in the term intelligence, like give me an example.
Off the top of my head.
All right, I'll give you an example of robotics, and one of the clients we talked to. We try to shy away from startups and unfunded clients. But at one point I was at IBM Watson event, and I was arguing with them about Watson is famously not very good, in my opinion, for speech to text. That's why I mentioned Dragonfly naturally speaking, because the SDK is, in my opinion, a little bit better. And one guy told me, he wants to talk to me about his product, and we met somewhere in the village. And he gave me a sad story about his father who came from Poland, blah, blah, this and that, and he's sitting at home and he can't move, and he's trying to build a robot that's gonna be like a nurse. And he wants to use my algorithm to talk to let the nurse talk to the father, and not just, systemic questions and answers. And, like a knowledge base, if he asks this, say this, if he says, how you doing, I'm doing okay, stuff like this. And he patented it and everything. And then he told me there's going to be a switch to it. And it's going to get weird now, guys, but this is what we see in real life. I told him it's going to be a sex robot. And he told me he patented it's a sexual robot, and he showed me a demo of a video. It was very creepy. But basically, the nurse is going to become something else. And I was telling him, that's very weird that you're doing this. $8,000 to buy a unit. He hasn't built it. He has his own prototype. He's looking for investors. And I'm like, why would someone even want to buy this?
It's already out there. There was an article today. I was reading about those things.
What? Really?
Yeah.
Did it come out? This is 2014.
Well, no, there are actual sexual robots out there.
That's it. Is the guy from New Jersey? I gotta look it up. Anyway, so even with that, it's performing one specific set of tasks. That sexual robot is not gonna go pick up the dry cleaning afterwards, or order on Seamless or something like this. So I don't know if you can call it general purpose AI. Now, I didn't want to get into this because I like to read philosophy, but I don't like to get philosophical with this topic. But throughout human history, a lot of humans arrogantly have been trying to become gods and create their own creation. That's the whole idea behind robotics and everything like this. In my opinion, a good robot is Roomba. I have a Roomba, I love it. It just goes all over the place, cleans it. It does one specific task. It doesn't have to have a face and eyes and ears. Why would I even engineer it like that? So far, I can argue with you maybe offline. There's no strong AI that has been demoed yet.
So you like R2-D2 better than C-3PO?
I like Blade Runner more than Star Wars.
Okay.
But anyway, let's go back to we have a lot of digitized content. Yeah. We still have how much time do we have? 5 minutes?
Yeah, a little more than 5 minutes.
Okay. So we still have digitized content. We have audiobooks. So you could say that if we have one of the tech giants can gobble up large amounts of data and make some decisions based on it. Most famous is IBM Watson. We have to mention that because it really is a powerful engine. It takes about 200 million pages of content, the full text of Wikipedia. It won Jeopardy. I don't know if you guys know about it. 2011, it won the Jeopardy thing. So AI platforms that come from the tech giants can absorb large amounts of data. A human can watch or listen to audiobooks for like 15, 16 hours. You have to sleep at one point. But an AI engine could absorb the audiobook information or keep on reading text from Wikipedia continuously, non-stop. And they're probably doing that at different companies. So they're going to be much faster than humans. But again, I don't know if they're going to be strong or general purpose AI. AlphaGo is another engine that came out of Google that won the narrow AI playing Go, which is an Asian chess game. Now, I want to mention something here. The way AlphaGo got so better, it played millions of clones of itself. So the algorithm cloned itself and played against itself again and again and again and again. Learning new strategies and discovering tricks on the way. This is called reinforcement learning. This is one of the cool things about AI. This is how the human, when I talk about the baby walking, it's called reinforcement learning, over and over and over again. It kind of is, when I say mimicking human learning, mimicking trial and error. You know, a baby, the spoon is hot or there's fire, touch it, oh, it pains me, I don't touch it anymore. That's kind of slow thing. Gradual, slow and steady, but again, you have to be something like Google with enough resources to run all these servers and all this computing power. The reinforcement learning was originated from behavioral psychology, and it's very similar to the way humans think, acquiring the ability to, when you discover how to swim, it's going to take you hours and hours of doing that. So we are on the cusp of learning by trial and error. Okay. So computers are on the cusp of learning by trial and error. This is very, very important and very, very cool things. And for many narrow, well-defined problems, specific problems, reinforcement learning is being used. So autonomous car driving or translating YouTube videos or providing captioning. But we have yet to see that being applied for human, strong, general-purpose AI, human-like intelligence. I want to mention here. So yeah, the future. It's the trial and error is a big deal. Reinforcement learning is happening very rapidly, but still is narrow AI. It's not general purpose AI. And strong AI learning like kids do. I don't know if that's going to happen anytime soon, but you never know. The explosion of computing resources and cheapness of it and the storage is important. So I know we will have to talk about process. So I'm going to talk about in the end, all machine learning systems or AI engines are basically computer or software systems. You have to think of them the way you think about the software implementation. I know the startup world, a lot of people think Agile is the one to end all methodologies. No. When you work in this industry, you realize, Richard Feynman talks about this, if all you know how to use is a hammer, all the problems look like nails, so you're going to nail them. Whatever the thing is, you're going to nail it with a hammer. You need to have a big toolkit with you as an architect to know this needs a hammer, this is a scaffold, this is a screwdriver. For each specific case, you have to use it. As a matter of fact, that's the only thing that's definite in my mind, is that everything is specific. That's definitely the case in my head. So waterfall actually sometimes works in this scenario, because you have to, remember how we talked about the parameters we gotta give for the hidden layer and the green number? I have to spend a lot of time analyzing what is the business and how do I set these parameters. The algorithm that's gonna go in and configure the hidden layer, there's a lot of work involved there, because I have to represent your assumption, your business, and what do you need to classify or divide out. That's a lot of work that has to happen. Then you can go into the agile later on, or the iterative waterfall approach, which is we do the design, we implement it once, and then we come back again, but through a slow cycle. You have to have a lot of data. When I say a lot, like huge amounts of data. Like for example, I'm going to talk about, so everything I said so far is basically the reality of AI. Now, I mentioned some of them are my opinions, like what I'm about to say now. This is my opinion. There's a whole section of people in New York and in the startup world that just pick up buzzwords and smash them together. Most recent is someone who's trying to build AI for smart contracts in Ethereum and blockchain. When I heard about this, the first thing I thought in my head, there's not enough smart contracts as labeled data to justify an AI engine. It's only 2 years old, or 3 years old. There's not enough data for you to train your AI algorithm. But still, people like these technical buzzwords and they mash them up together. So you have to have a lot of labeled data in order to mimic and represent reality. In our scenario, it was 2 features, granularity and density. This is not real world. Real world is hundreds and thousands of features, and 200 rocks is not going to cut it. You need to have like millions of rocks. In finance, we did some work in equities. You have end-of-day data since 1970, and you can gobble all of that up, and each stock, let's say IBM.N, would have multiple indicators with it, saying what was FFO, EPS, or whatever stuff, and you have to talk to the quant to see what is his macro trading strategy, and build a classifier based on that. So there is no specific way, but you have to get the client involved a lot. Agile could come in towards the end, but there should be some slow, I don't use the word slow, but the waterfall does work sometimes. And most of the time it works in the AI engines. Any questions so far? Any question, doesn't matter.
With waterfall agile, you're talking about the way you develop it, or you're talking about
The head of the project.
the way you handle the project?
Yes, yes.
Okay, that's.
Well, the way you develop it too. For example, you spend with waterfall, you have to analyze the problem itself. So requirement gathering, stuff like this.
So, I mean, a lot of the machine learning conferences I've been in, before you even start to analyze the data, you actually have to prep and clean the data and create a pipeline.
Yes.
And that itself takes half a year to a year
Yes.
of dedicated resources before you have useful information to start modeling on top
Yes.
of.
Garbage in, garbage out.
Yeah, I remember. I mean, I didn't want to, but I had to use the word garbage. But really, it's the case. The computers don't have consciousness or awareness. If I give Watson a Wikipedia page that says, off the coast of China lies the great empire of America. In the empire of America, they have sushi burgers since the 1600s. It's not going to question that. This is reality. And I'm going to say Japan is between Canada and Mexico. And the Japanese state, the United States of Japan here, for example, Tokyo is next to the Hudson River. That's a fact to it. It's not going to be able to analyze or decide anything like that. If you give it, whatever you give it, that's the data that it believes in.
Yeah, I would think a major distinction or criteria for deciding between waterfall and agile are the stability or lack of stability of initial requirements. So if it's very stable, you can go with waterfall. if it's volatile, you really need agile. And I think the same would apply to AI development.
Can you repeat the question again?
I'm distinguishing between using the criteria for choosing waterfall or agile. If requirements are very stable, they say it's easier to go with waterfall. But when they're volatile, the market's changing, the competition's changing, you need to be more in an iterative approach. So I think that applies whether it's AI or not.
Well, yes, your statement does, but the problem with AI is there's a lot of domain expertise you have to have. You have to, so
No, I'm
other
not-
than
I'm not-
cleansing the data,
I'm not moving away from that. So
Yeah.
coming back to the Mars example, if it was a fixed requirement, we just, for the next year, that's all we need to know to distinguish, we're okay with waterfall, we're stable in developing whatever software we're
yes,
developing.
yes.
But if the management and NASA are saying, oh, every 3 months they're changing their mind, then we've got to be more literally agile in meeting those changing requirements.
Yes, well, I mean, how much of a change of a mind it is? I mean, are they gonna add new features?
Yes. So,
That could destabilize the whole
this-
project.
This could drive the changes in the architecture of the neural network.
Yeah, and that could make you have to restart the project.
You go crazy in the end, but you know,
Yeah,
you can't,
yeah.
if they're gonna change their minds, you really, I think you're gonna be reluctant or shouldn't use
Yes.
waterfall.
But this applies in general, yeah.
And, yeah.
Can I add one thing quickly? For people who are doing research besides machine learning and strong and weak AI, there's some alternative approaches. Specifically, if you look up Jeff Hawkins, he created the Palm Pilot. He's working on a project called Numenta, where they're really modeling the human brain, not, you know, they're taking a different approach to it. So it's something worth looking out for.
I mean,
The
okay,
idea
I mean-
came up is that you have a child and you point it to a puppy. How long before that child looks at the next one and say, hey, puppy?
I mean, I'll clarify, yeah, if you can look up whatever research you want, but just remember that it really is a very specific field. And you should approach it as a student. Don't assume that because you read a couple of articles that you really know all the details of it. There's so many different approaches. Hundreds of AI research is being published yearly, and multiple universities are doing it. In this talk, I try to show the mainstream ones. I mean, there's different areas of it, but the mainstream ones are machine learning and neural networks. So I think that's it.
Thank you very much. So we're gonna pass around